Where are we at? Okay. So I've been thinking about this all day. Yesterday I wanted to stream longer. It's getting good. No, it's fun. It's sharpening my programming abilities, I think, to do this. And here I read about this. What we're gonna do here? What we're gonna do? Hold on. I read about where are we at? Computing cofactors, implementing inversion. Okay, determining determinants of larger matrices. Okay, we're determined to find the determinant here. Okay, so the way that you find the determinant of a 3x3 is pretty interesting here. So okay, set the stage prior to the following test showing the determinant and some of the cofactors of a 3x3 and a 4x4. Don't tell me what to do. I'm just kidding. So the cofactors are interesting. It's positive or negative based on the sum of the indices within the matrix, which is interesting. Okay, calculate the determinant of a 3x3. So finding the determinant of matrices larger than 2x2 works recursively. Consider the 3x3 matrix from the previous tests. To find the determinant, look at any one of the rows or any one of the columns. It really doesn't matter which, so let's choose the first row. Then for each of those elements, you'll multiply the element by its cofactor. So for the first element, which is 0, 0, in this case it's the number 1. So you take the cofactor of 0, 0, which is the submatrix, or cofactor. Okay, and we already know how to do cofactor. Okay. And that's the determinant. The magical thing is it just doesn't matter which row or column you choose, it just works. Excuse me. So any row or any column. So why don't we do in a 3x3, right? Why don't we do, hold on, I gotta put this back. So what, excuse me. What do we do in a 3x3 here? What do we got? We're still in the same chapter, so I'm going to leave a lot of this code in here. But 2x2 matrix. I have some new music going on. Let's just clean up here a little bit. Create 2 4x4 matrices. Okay. Submatrix get minor cofactor. Okay, so and 442 is the 1. Let's move this back up here so I can work with it. Okay, this one sounds really cool. What is it? Gathering 3 Astroneer. Cool. I like it. I like it. Should I move that into favorites, do you think? Astroneer, gathering 3. Copy. Steam favorites. Paste. That's why I'm going through these, so I can find my favorites. There we go. There we go. Okay, so we got a 2 4x4s. What we want is a 3x3. So first sub is a submatrix, so it's a 3x3. So let's go first sub show. Sounds like you're trying to make contact with an alien or something. Sounds cool. Close encounters of the third kind. Okay. So I just had a cookie, some sugar, and 2 orange juice. So I'm kind of loaded on sugar right now, so pardon me. Okay, 122217318. Okay, is that a good one? Should be a good one. What's this one? Why don't we do the second one sub 00? So let's change that to 00. Okay, so there we go. 232.167 negative 158. Okay. Now we got Heartbound going on. I'm Thor, everybody. Welcome. It's Thor. Alright. Still too loud. I'm turning this down. Turn it down. Okay, so to find the determinant, look at any one of the rows or columns. So the first row, so in the first sub, right, it's 3 by 3. You want to go like this. Int I 0, I is 3, I 0, 0, plus plus. So to look at the first row, we're just going to look at first sub. Okay, so the thing is, we want to multiply the first, we want to multiply the element, so first sub dot data. And the first row is going to be I 0. Or is it going to be 0? Yeah, 0i. Okay. So that's the element that we're going to multiply by the determinant, or the cofactor. So first sub dot get cofactor. And the cofactor we want to get is of that particular element. So it's going to be 0, comma I. And then we want to multiply that, we want to add it in a sum, so we're going to go like this. Total sum equals 0. Okay, and then when we're done, we're just going to say std out, cout, determinant, total sum. Boy, this music sounds way better than when I listen to it on Thor's stream, because of course he keeps it turned way down so people can hear him and stuff, but it sounds really good. What's going on? Good music. I didn't buy Heartbound the game, but I bought the soundtrack because I love the music and it's really good. Okay. So total sum, first sub, all that. So let's see what that does. Theoretically, that should be it, right? 0, 1, 2. Determinant is 3. Okay. Oh, I guess I kind of have no way to test that unless I do it. And well, we can use a calculator. Let's see. So the first one's going to be 0, 0 times, which is 2, okay, times the first cofactor of that, which is 48 minus 35. Times 2, okay, 26. The next one's going to be 3 plus parentheses 3 times another parentheses. So 3 times 8 minus a negative 7. So 8 plus 7. 71 so far. Okay, so what's the last one? 3 times that, okay. So 2 times 5 minus, so 2 times, oh but wait, the cofactor, did that supposed to be negative? Oh shoot. 26, hold on. So it's negative 19, gotcha. Plus, parentheses, 2 times, parentheses, 5 minus 6, 11. Oh, 3. Oh, that works. Okay, and I did it right. Okay. Okay, we got it. So now we have a way of determining the determinant. Did I just say that? I have a way of determining the determinant, finding the determinant, whatever you want to call it. Alright. Right here. Of a 3 by 3. So, oh, let's do another one. Let's do another column or something and just prove that it's the same, right? Let's do a column this time, so we'll swap, we'll go I, 0, I, 0. This is kind of really cool. I can't believe it. Just kidding, matrices are crazy. Yeah, so no matter what you choose, you're going to get the same determinant. So that's really cool. So let's choose, or let's put this into a 3 by 3 matrix. So where is the get determinant? Determinant here, rows equals 2, columns equals 2, that. Oh, I got you. Okay. What? So return, if it gets to this point, we're just going to return. Just taking out the else. So that's the determinant of the 3 by 3 right there. So now how do we do this for a 4 by 4? It's probably going to be exactly the same. It's just that when you do the 4 by 4, if you choose a column or a row, each one you're also going to be doing the submatrix. You're going to be doing the submatrix for each particular element. So 3 submatrices, the determinant of 3 submatrices, which would be 4 submatrices, excuse me. So you're going to be doing 4. Oh, and are they also cofactors? All right, hold on. They are. Excuse me, that's the magic. Okay, it just works. Let's go to a 4 by 4. Look here. And it works for 4 by 4 matrices too. Here, consider the matrix from the rest of the test you wrote. Again, you only need to look at a single row or columns. Let's choose the first row. Let's multiply each by its cofactor. Okay. Voila, the determinant. There's no denying that's a lot to process, though. To give you a leg up, here's a bit of pseudocode for that algorithm. Determinant is 0 if m dot size equals 2. Determinant is that times that is that. Else, for column 0 to m size minus 1, determinant equals determinant plus m0 column cofactor m column. Oh. End for and if returned at. Oh. Go ahead and make those tests back. Oh, you're funny. You're a funny guy. Funny guy. So let me see here. So will this work? This is not going to just automatically work. This is not going to just automatically work. Actually, let's see if this works. Determinant return total sum. Let's go back here. So let's go first sub dot determinant. Or let's just put it in a total sum. There. So let's make sure that works too. Determinant 3 and okay, so that does work for a 3x3. Because I told it to do the 3 of them. So when we do a 4x4 now, is there anything on Restream? If there's somebody on YouTube, I apologize. I don't usually see the chat for that. And this only shows new chat messages. I guess I can go look on YouTube real quick. Just to see live. I'm live. Oh my god, I'm alive. Okay, nobody's been here. Good. Good, whatever. Nobody watched this till later. Just kidding, okay. So that works. So what we need to do is just, yeah. So let's do the first one. Let's do it up here like we did the other one. So that determinant right there, that's for the 3x3. Okay, so we don't really need to do, or we don't want to do this, do we? Excuse me. So we start with this 442. So to do, okay, the 444, so what we would want to do is, we already have total sum, so we can just go total sum is equal to 0. What's happening in my ears right now? What's going on? What's happening? I feel like I'm being hypnotized. Okay, so total sum plus equals, and then what we want to do is multiply the first dot data sub, let's go I 0, okay. So the first sub is now equal to, I got you, so we go first sub dot, or wait, first sub dot sub matrix. And when we're doing submatrix, we're doing I, comma 0. And then that one is, wait, no, submatrix. So then with that submatrix, we want to find the determinant of that, right? So we have to actually go up here and go matrix temp 1 equals this. So we're going to take this submatrix there, and then then we can get the determinant of that. Then we can go times temp1 dot determinant. There we go. temp1 equals, so that'll work right there. Am I right? First sub dot cofactor. Oh wait, no, we're getting cofactor, not submatrix. Apologies. Cofactor, right? Get cofactor. Because we want to... Uh-oh, hold on. No. We'll let the thing take care of the cofactor. The determinant function... Okay, I got lost for a second. The determinant function calls the get cofactor and everything's everything's fine. Everything's fine. So when it's determining the determinant of the 4x4 and we're getting the submatrix, that's the... Isn't that the cofactor? So then don't we also multiply by... So when it's a 4x4 and we're getting the submatrix, this is the submatrix here, but what about get cofactor? Get minor, get cofactor, get minor submatrix, return determinant. I'm so confused right now. I'm lost. It is undetermined where I'm at. No. Whoops, wrong screen. Okay, so where are we going? We want to go here. Wait, so submatrix, total sum. Wait, it tells me right here, actually. Did we cover cofactors of 4x4s? I'm so confused. Alright, let's look at some of my code that I have commented out. Did we look at cofactors of 4x4s? Make identity multiply. I don't think we covered... Excuse me. So getting the cofactor int RC get minor, it's only for the 3x3, right? Cofactor, yeah, get minor, RC return minus 10 per temp. Submatrix, return the determinant. So what if it's a 4x4, right? We never covered that. Is it the same thing though? Wouldn't it be the same thing? So, hold on. So getting the cofactor, if it's a 4x4, let's go like this. Go to Bing. I'm pretty sure that I know what the answer is here, I think. I just don't want to exhaustively go through it all. Wait. Okay, 1086. So I could have copied almost 4 times as much of text in there. Sure, I can help with that. Here's how you calculate the determinant of a 4x4. You can use the same get cofactor and get minor functions, but you need to update your determinant function to handle 4x4 matrices. Okay, good. Get cofactor 0, 1. That was it, that's what I thought, but then is that just... So get cofactor 0, 1. And then when it calls the get cofactor on the smaller one, it gets the minor, gets the submatrix, gets the determinant, it goes through all that. Okay. I got you. So that is what I thought. Oh, and it cleans up my code with the else if. Let's just copy this whole determinant function here. What is this from? Blood Moon. Oh my god, that's cool. Kingdom. The Kingdom series is good. I bought it, but I was disappointed in the Kingdom 80s. I just haven't played it. Maybe I need to play it and get into it, whatever. Okay, so let's go like that. The determinant. Alright, let's try it. This is, yeah, it's just the fact that this will call recursively down through kind of messes with my brain just a little bit, but should work. Hold on. So I actually don't need that. We just need to go total sum equals first sub. Or no, not first sub, because first sub is the sub matrix. We want to just jump right up to mat 44, 42 determinant right there. And then we don't need that, and then we just want to see std out. Oh, and I can just copy that from here. I'm being lazy. Need to be lazy? Okay, whatever then. However, my brain works. Determinant 0. Oh. That doesn't seem like a good answer. Is it? Get cofactor. Okay, so hold on. Get cofactor 0 I. Get minor RC. So get minor temp submatrix there. Return temp dot determinant. Determinants are a sensitive thing. How large are your matrices going to be? What's up, Meatball One? How you doing? Meatball One. Interesting name. If that was a plate of spaghetti, I would want more meatballs. No, we're only working with 3x3s and 4x4s, and that's it. 2x2, 3x3, 4x4. Per Jameis Buck, per the book, the Ray Challenge, the Ray Tracer Challenge. And yeah, so I think it has to do with when it gets in here. And I think what happens is determinant. Couldn't use the same principle, but it sounds surprising. Okay.
It was supposed to be a funny name for a spaceship. Meatball 1, requesting docking. I thought it was funny.
Supposed to be a funny name for a spaceship. Oh my gosh. Meatball 1 request. That's hilarious. Meatball 1 requesting docking. Meatball 1 is about to launch. Prepare the sauce. It's a recursive process. Okay, so I think what's happening is right here it's returning 0. So it's going to add them all together. It's going to be 4. Let's return 2, because I bet that's it. And I need to put in a thing for get minor if it's that. And then son of a bean. Yep, it's -4. So I think that's it, but I don't know why, and I'm scared. I don't know why, and I'm scared. I'm scared. Oh, no. Ready to lunch? I mean launch. That's a good one. What you doing, man? Are you a coder, programmer, game dev, lonely soul, full of people in your life? What brings you to the stream? Let's see. And how are you? So I think I just need to go into here, and I need to think about it. And so let's isn't my, so I think I copied that code into Bing, so I can ask Bing about that. See if it responds here. Yes, you're correct. Oh, yes, that's it. I knew it. See, I knew it. Okay. Bing. What are you doing? What are you doing to me, Bing? Why are you doing this? Uh-oh. Uh-oh. Here it is. There, it's coming up. Okay, I can't tab away. It's thinking. It's finishing the essay. I'll be right there. This code creates a new matrix that's a submatrix of the original matrix with a specified row and column removed. Then calculates the determinant of this new matrix. Is using the calculator to call the element. Please note something. Okay. All right. Good. So this is all we have to do. And let's just take the whole thing. Copy the whole thing. Get minor. We're going to update the whole darn thing here. That's it. Okay. I'm a physicist. Whoa, that's cool. And I wish to help people however I can because I feel one of the most important activities is sharing knowledge and experience. Dude, that's awesome. That's crazy awesome. A physicist. So determinant 6. I have no way of knowing if that's true. I have to assume that it's correct because the number is, what can we do here? Oh, I know. Hold on. Let me adjust my glasses again. Okay. Let me simplify the determinant involved in multiple sum of the n subdeterminants. Exactly. That's it. This continues on recursively until you end up with a 2 by 2 in submatrices of size 1 by 1, which is, yeah. Exactly. That's it. You are a nerd. Confirmed. Meatball 1. Confirmed nerd. Excellent. You've come to the right place. Okay, so this does the 4x4. And, so let's do another one. So let's do, like it says here, determinant. Determinant. Shoot. Oh, right. I just do any. Okay, let's. I don't want to do. I'm just going to hard code another one in here because I just want to total sum 2 equals 0. Let's do a column instead. See if we get the same answer. And we don't want to print. We don't want to return that. We're just going to print it. Let's say D2. Call the first one R2. No. Okay, sorry. Alrighty. So let's print the other one too. This I know I'm messing with this function that I don't really want to mess with, but we're doing it. We're doing it. Total sum. Uh-oh, we still have squigglies. Why? What did I do? Oh, don't do that. Okay, total sum, total sum, total sum. So we're just going to return the first one. That's fine. But we'll print both of them because I want to see. They should be the same. R2 and D2 should be the same in this case. It's wrong. You've done it wrong, son. Oh dear. Okay, so there is something still wrong, and I think it's probably with the cofactor co-thing. As you see involves, yes, it's true. It's an issue if you're making a very varied values. Computers tend to, when we're seeing a very last one, it's floating point math. That's true, but what's this one? Astroneer gathering 2. I kind of like that one. Boom. Well, now I'm kind of.
Astroneer is indeed quite nice.
Oh, Quantum's raiding. Wait, you're over already? I was gonna come raid you later. Quantum.
Not a mod or nothing.
Quantum, what up? What happened the rest of your stream? What happened? But he was doing Baldur's Gate 3 on a brand spanking new PC. Looked better than ever. Frames win games. Just wanted a short stream to test out Baldur's Gate. Cool. It was pretty cool. It was pretty cool. So I really messed up doing the 4x4 matrix here. Or determinant of the 4x4 matrix. The first computation is a what is it, a row? R2. The second one is a column, D2. And they're not equal. They're supposed to be equal, and it's all messed up. I blame Bing. I blame Microsoft. So I wonder why? Why? So when I go submatrix 1, I know it's R2 and D2, but we're gonna go determinant 4x4. Okay. Because I want to know where it's at every step of the way here. And this one we're going to go std cout determinant 3x3. And then we're just going to print it. So as it's calculating these things, I will see it on screen. R2D2. It's true. 2x2 I don't care about because we already do the 3x3. 3x3 we're good. So we're just gonna follow as it does these 3x3s, and I want to see get minor here, submatrix. Oh wait, is this it? No. Nope, that was not it. Okay, so let's get minor, get cofactor. See, I'm so confused. I think that's gonna work. So get minor, get cofactor. So get cofactor here. Let's just put in a little temp equals get cofactor, return temp. Let's just return negative temp, positive temp. Okay, we don't really. Cout. Get cofactor Actually, let's make it look fancy. R. So that'll tell me it's calling the get cofactor. Let's copy that for get minor down here. Do we want to specify 3x3 or 4x4? No, let's just put it up here. Oh, that's got the same variables. Okay, cool. Okay, so I think it's just those. Oh, submatrix, do we want to? Doesn't call determinant get minor submatrix. It calls those. Matrix result. We could do that too. We could just put it in here. I don't particularly care. Let's just see what that does. Holy Lord, look at all that. Okay, so this... Okay. Computer. Okay, so get cofactor. Put it in a spot where it's a little mini generator. 0, 0, 0, 0, 0, 1, 3. Oh. So wait, 1, 2, 3, 3. 1, 2, 3, 3. Determinant 3 by 3, 3, 3. Oh. Determinant 3 by 3, 3. 3 by 3, 12. 3 by 3, 15. 12. R2. We got our first R2. Oh. I don't know, bud. I don't know. Oh. Yeah, and then it just prints. Okay, so I'm so scared. I don't know why. All right. So it's only get cofactor, get minor. Okay, so let's see if we can. Now get cofactor. Is that returning the proper temp get minor RC plus? So that should be doing the proper, because if get minor and it's this, is it one of these submatrix determinant submatrix determinant? Suddenly I'm like, did I save this before I modified this tonight? I didn't, so I messed it up. Actually, which isn't really true because I can just take out the stuff I added in. All right, well, let's just see. Let's go like this. Watch this. Watch this. Just mentioning about doing this on paper helps a whole lot. Oh no, no, no. Oh no, no. No, meatball one. No. We're not gonna do this for sure, not gonna do it on paper. Those were my college years. We're done with that. We're gonna go to Bing. Okay, so okay, that's what I was thinking. Submatrix, I think, is fine. What? That's it? A correction to the get cofactor function? That's it? No. Oh. That could be throwing it off though. So oh, hold on. I don't think that's it though. Let's take out a lot of this other stuff. If that's the only thing, I don't know, it could be. It's recursive, and if there's a small error, bum 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 bum. All right, try it again. Here we go. Oh wait, did I? I forget what I'm seeing here. Determinant. What are we getting? 4 by. Oh, 4. Oh, hold on. We took out the R2 and the D2. Didn't mean to do that. Sorry, R2. And oh, it works. So that was it. Oh my gosh. Bing to the rescue. Bing. Saw it here, folks. Raticide, what up? Well, since you use Bing Chat, I'm going to use ChatGPT. Awesome. I mean, since I'm paying the subscription for the 4.0 model, might as well. I was paying the subscription for the whatever model, okay? And then that thing happened with Sam Altman, and for some reason, I don't know if it's a coincidence because my subscription canceled, or not canceled, but was set to be resubscribed at that time. I went to resubscribe and it wouldn't take my money. So I was like, okay, fine. And I looked over at Bing, and you know what? Bing is using GPT-4. So I started using it, and it's free. So all of a sudden I'm like, what am I doing paying for ChatGPT? And I never went back. But I absolutely love ChatGPT, but I'm good now. So I don't know what happened, but I definitely don't want to pay for something I can get free. Bing also makes images. So does ChatGPT. They just added a whole bunch of stuff. They also added the ability to create your own kind of like personalized ChatGPT, and they have the whole ChatGPT marketplace, which is really opening up a whole cool thing. But yeah, I didn't get into any of that. But I was gonna, kind of, I guess. I don't know. I'm happy just getting code that works. Test it, verify, move on. Okay, so the next section here is the final section, I believe, implementing inversion. And then we're done. I can't believe I got a determinant for a 4x4. That's pretty good. Okay, you're to the culmination of this whole process. Here's where it all comes together. Remember, inversion is the operation that allows you to reverse the effect of multiplying a matrix. Oh, this is, okay, so this is where the determinant comes in. I remember now, because I read this last night before bed, too. It's crucial, rotate, overstate, tricky, Testing an invertible matrix for invertibility. Testing a non-invertible matrix for invertibility. What? Oh. If the determinant is ever 0, the matrix is not invertible. Oh. Anything else is okay. Oh. Ah. Well, that makes sense because you're dividing every element by the determinant, which would be by 0, so. I never understood the math to invert a matrix. Well, we're going to go through it right now. Basically, what you do is you take every element in the matrix. See, it's no accident the test also calculates some cofactors and determinants, and I'll release the algorithm for the inversion itself. That algorithm consists of several steps, starting with the construction of a matrix of cofactors. That is, you create a matrix that consists of the cofactors of each of the original elements. Oh, really? Then, then transpose that cofactor matrix. Then transpose it, okay. Finally, divide each of the resulting elements by the determinant of the original. Oh, that makes sense, because you're transposing it. Oh. Okay, this is going to be cool, right here. This is going to be cool. Because I love how he just set me up to literally do this, which is crazy. I've only been streaming for 12 minutes. Did I drop stream here for a little bit? Did my stream drop out and come back? What happened? What happened? It says 50 minutes here. Oh, I did drop. Did I drop the stream? Twitch, what have you done? Yeah, see? 12 minutes. Weird. 12 minutes ago. Alright. Anyways, okay, so we're going to do this. Okay, so the first thing here. So we need to create a new matrix. And this one I don't have to manually put in the values, so I like that. A lot. Okay, so let's go up here, Oh, wait, no, we're not in main. Go in main. So what we have is these matrices here. Let's go with the second one we've been working with, la-di-da here. We're not going to need R2 and D2, although they were really fun and cool to have around. Thank you, guys. In fact, we don't even need the whole second calculation there. And we don't need this. We can take out that, just clean up a little bit here, cofactors, get minor, all that fun stuff. Okay, submatrix, okay. Alright, so the first thing we want to do, the first thing you want to do with your 4x4 matrix is knead the dough very well. Sorry, I'm in a funny mood now. Oh, I need to just comment all this out. Okay, so 4x4, where are we at? Beep, bop, boop. Okay. Create a matrix that consists of the cofactors of each of the original elements. So does this work? Cofactor, get minor, it does. Okay, I'm scared. I'm so scared. I'm scared. Okay, so we're going to create a new matrix. We're going to call it, what, inverted? Alright, inverted 442. It's going to be a 4x4. Okay. And then we're just going to go inverted 442, parentheses, I, comma, j, equals matrix 442 dot get cofactor. Oh, no, just son of a bean dip. So we want to get cofactor ij. That's it. Cool. Let's see what that does. Wow, cool. Look at that. Isn't that cool? Wow. I'm so excited. I'm so excited. Just a lot of numbers. Okay, transpose. So then we're going to go inverted 442 dot transpose. And then show me. Hi, yeah. I still remember I learned the STD swap for that one. That's cool. Like, I didn't realize that this was a thing. You could literally just swap two places in memory with one command instead of temporary and all that other fun stuff. Okay, so finally divide each of the resulting elements by the determinant of the original matrix. Okay, so now we need the determinant of the 442, which we had at one point, but we lost. All is lost. We can never regain what we have lost. It will never again come to the kingdom. Wait, what happened? Oh. Total sum equals that, so the determinant. So now we need to go through. Let's create a new function just to do this, because I don't want to do this like that. I don't. Where's that? Submatrix? Matrix, submatrix. That's a function. Let's just put it right up here after the constructor. Let's just go like this. Void invert by this. No. Invert by this amount. So just float div. That's what you're going to divide by. Can I use that? Is it freaking out? Is that a keyword? Okay. It's not. So then we just want to cycle through all of the wait. Invert. Hold on. I forget because we could be doing this for any matrix. There we go. So then we're just going to go data I, j. Can we just do this? Divide equals like that? And then go by div. And then we're done. That's it. So that will give us the inversion. So then I can just go. So now we want to do. We want to do inverted 442.invert and show total sum invert total sum. We got to put that in there. Okay. Now we're gonna get. This is the actual. That's the inversion. That's the inversion right there. So to prove it then, what do we do? Multiply that by that, and then we get 1, right? Certainly possible to do exactly what the preceding example suggests. Find the major transposing it. You can actually do it a bit more efficiently by what? Combining the operations. Here's some pseudocode. Wait, I don't want to do that. I've already done it. Fail if m is not invertible. Oh, I forgot to check for that. Row 0 cofactor divide. Oh, I see. Okay, yeah, that's fine. Oh, whatever, it's fine. It's fine. I did it. Okay. It's important all this is correct. Any bugs in the code now because they're going to head down the road. Version of the matrix. Yes, that's what I want to do. Add one more test to show that the inverse does in truth behave as described. Okay, so let's multiply it both ways because I still want to see. I want to see what happens. Like one of them should be 1 and then the other one should be just like, I don't know. Right? So what are we doing? I don't even remember how to do this now. Can you even multiply, bro? No, I'm kidding. So, matrix 442 dot multiply by inverted 442. And what does that return? Doesn't that return a float result? Matrix result? Oh, the identity matrix, right. Oh my goodness. Matrix result. Result.show. Bum, 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 bum. And just to make sure, I'm just gonna, not make sure, but just kind of see what happens really. inverted 442 dot multiply. Oops. Multiply tuple, son of a... Excuse me. So right before this one, stdc out. Identity matrix. Okay. Such pain. Oh, wait, look at that one. That is an incredibly small number. Not sure what this is, but hey, you wanted to do it. So look at that one. So we get the identity matrix except for one of the numbers is an incredibly small number. What? What? And this one, look at these small, incredibly small numbers. E minus 16. What in the... So let's just a second here. When we're go back into here. So invert data divided by that. I don't think it's that. It was the multiply. Yeah, multiply. Where's it at? Computer, show me your multiplication. Yes. Result equals that. Okay. So I'm just going to put a little check in here. If result.data ij is less than 0.001, then result.data I computer, I can't type, equals 0. Alright. There's probably more places we can do that. Wait, identity matrix, what? It didn't work now. We're screwed. We're completely screwed. You're so screwed, dude. Okay, so that's but it's just what? What? What happens? What happened to you? What happened here? Did I just... Is it... What? I didn't change anything. Okay, so what is going on? Okay, so right here, this is good. Identity matrix. So to get the identity matrix, the only thing I did was multiply those, right? What is happening here, Watson? Yeah, 442 multiply inverted. Transpose matrix. Okay, so 442. Let's take out this one. Take out this one. Inverted total sum. I only want to see the last one there. And then I want to see, and then I want to put right before that show. I'm going to go make sure I know. Inverted 442. Okay, inverted 442, identity matrix. Okay, so it is, and this is 442. Okay. That's a very small number too, right? It's not E-15 like a very large number. That's a small number, right? Oh, sorry. Scroll to see, oh, I wasn't there. Then scroll up, you'll see me asking what happened. Oh, okay. If your name wasn't Jeff, would you still be a programmer? If my name wasn't Programmer, I'd still be a programmer. Why does it always do this? I don't want to see anything else but the chat. Why? Okay. Is this a small number? Yes. Okay. That's what I thought. Multiply that might not be the only problem, but I suspect that is. When you multiply a matrix by its inverse, you should ideally get the identity matrix. However, due to limitations of floating point precision, you might get very small numbers instead of exact zeros. These small numbers are referred as machine epsilon. They represent the round numbers. The comment line here is trying to set these small numbers to 0, but it's not working because it's inside the innermost loop. Because it's inside the innermost loop, at that point the computation for a result is not you. Oh, did I miss that? Clean up small numbers. Oh, just put it afterwards. So, oh, because it's, okay, hold on, no, finish your essay, good. Okay, I forgot there's a K there. Oh, I see, doobly dubs, we've missed the innermost loop. Oh my goodness. You've missed your innermost loop, Watson. Okay, hold on. Boom, boom, boom. Other rows, other columns. Is everything right here? I'm checking, Captain. Preparing to check. Preparing to copy the function in place from the AI. The function has now been enhanced, Captain. Rerunning the program to test. The answer. Oh, it works. I'm not sure what what? How come it gives the thing? Oh. What happened there? Oh. So, what? So if I multiply the inverted by the matrix itself? Oh. Ba-da-ba-ba-ba. What happened to the music? Found? Sounds like I've found silence. Silence, I tell you. It sounds like there's like some kind of a... Yeah, okay, moving on. Insane shadows. Okay, so, sorry. Yes, that's absolutely correct. When you multiply a matrix by its inverse, the result should be the identity matrix. This holds true whether you multiply the original matrix or the inverse. Oh, the identity matrix lies the number 1 to the number. Sounds like your matrix version wasn't written correctly. Great job. Oh, okay, cool. Okay, you saw it here, folks. Programmer Bob. Programmer Bob doing it. That is the end of this chapter. That is very exciting. Putting it all together. You now have 4x4 matrices with support for multiplication, transposition, and inversion. Not bad. Sadly, there's not a lot related to ray tracing you can do with those routines just yet, but we'll take care of that in a little bit in the next chapter. Matrix transformations, however, there's always room for a bit of experimentation. Before moving on, take a few minutes to explore a little more. What happens when you invert the identity matrix? What? When I do what to the who? Invert the identity matrix, you say? Now I completely forgot how to invert something. Am I supposed to invert total sum? So, result dot determinant. Apparently it's supposed to wow us. Just kidding, I didn't say that. Okay, show me that. Identity inverted. So what happens? Identity inverted? Wow, you get the identity matrix, bro. Wow, bro, really? Cool. What happens if you multiply that by itself again? Wow, bro. Okay. Cool. Nerdy cool. That's nerdy cool. Okay, what do you get when you multiply a matrix by its inverse? What do you mean? What? The matrix, isn't it? Or no, you get the identity matrix. Didn't we just do that? Computer, why are you asking me this question now? Is there any difference between the inverse of the transpose of a matrix and the transpose of the inverse? What? Huh? What came first, the chicken or the egg? What? Is there any difference between the inverse of the transpose of a matrix and the transpose of the inverse? I'm going to just say yes and move on. I don't want to look at it. I don't care. Remember how multiplying the identity matrix by a tuple gives you the tuple unchanged? Now try changing any single element of the identity matrix to a different number and then multiplying it by a tuple. Oh, okay, I got you. It's just setting the stage for like what does matrix transformation actually do and how does it work? I actually know how it works, so I know what he's getting at. I got you, bro. Okay, it's past my bedtime, but I took like a 3-hour nap earlier so I could stay up later. I could totes stay up later. But I don't want to go on. I kind of do. Who is Joe? A former co-worker, best friend Joe. What's up with that? What's up with that? Translation, scaling. Oh, that's cool. Translation and scaling. What are radians? Radians are what? What are radians? Oh my goodness. Radians are angles. It's a measure of an angle, right? Rotation around the y-axis. Rotation. Shearing. Oh, what's shearing? Transformation is the effect of making straight lines slanted. Okay, it's probably the most visually complex transformation that we'll implement, though the implementation is no more complicated than the others. When applied to a tuple, the following illustration shows how it works in 2 dimensions. Are we going to be doing the, what's that drawing line algorithm? Chaining transformations, putting it together. Oh, that's not too bad. That is not too bad. Matrix transformations. Ray sphere intersections. We're already ready for that. Oh my gosh. That's cool. Okay, so I'm going to read this section on matrix transformations before I go to bed. And then I'm totes going to be doing this tomorrow. I was training the new guy at work today, so I kind of had, I don't want to say it was an easy day because at McDonald's, there's always something to do. So I was doing dishes instead of doing the drive-thru. But tomorrow's just going to be just me on the drive-thru and dishes. So, actually they might have somebody else to help too. Okay, thanks everybody for tuning in. What do we have? 2? Where did everybody go? Let's see if we could raid Mr. Wiggly. I know I only have 2 people, but that's fine. That's part of the thing that Twitch wants you to do. Mr. Wiggly, here we go. Do we have ads when we first tune in? Let's get through the ads if there are.
And it does show that there is an audience for people watching other people make pizza.
He's talking about Pizza Princess
Yeah,
G.
her streams are great.
All right, we'll say hello to Mr. We're unable to raid
Right,
Mr.
see what
Wiggly at
happens.
this time. Okay, well then we're ending.